So if we were going to evaluate the log base 4 of 7, what would we do? Without a calculator. Can't do it, right? Okay, because we can mentally think of some numbers, right? 4 to the first is 4, right? And 4 squared is 16. 7's between 4 and 16, right? So our power would be somewhere between 1 and 2, but we don't know. Probably closer to 2 than the 1. Okay, so 1.5 something, but we don't know, right? How would we do it with a calculator? Because we don't have a log base 4 button on our calculator. There's a log button, and that log button allows us to say the log of what over what? 7 over the log of, that's our change of base formula. Okay, but do you know why it works? No. Okay, do you want to know why it works? So let's let this equal x. Okay, if we're going to let that equal x, then that means that 4 to that x equals 7. Okay, then just like with anything in algebra, if we do something to one side, we can do the same thing to the other side without impacting the equality of both sides or of the equation. So what's your favorite log? Log base 10 or natural log? Log base 10? Okay, we like log base 10. We're going to say the log base 10 of 4x, 4 to the x, equals the log base 10 of 7. Log base 10 is our common log, so it's the one that doesn't have a little base below here. It's one of our 2 log buttons on our calculator. These are current, yep, these were the log base 10 because it's our common log. If your favorite one is the natural log, you could have taken the natural log of 7 and divided it by the natural log of 4, and your calculator will give you the right answer either way. So they'll get you the same thing, as long as you don't mix them. You can't have a common log with a natural log and vice versa. It has to be the same log that you're using. Log 10, base 10, log base e. Okay? So here's the cool thing about this. Remember when I told you that the answer to a log is an exponent? Okay? So right here, we have an exponent to an exponent. So when we have a power to a power, what do? If I have a power to a power, what do? Multiply, okay? That tells me that I can take this power and put it in front and call it the x times the log base 10 of 4 equal to the log base 10 of 7. Okay? How do we get the x by itself? Divide. Change of base formula. Okay? So what is the log base 10 of 7 divided by the log base 10 of 4? On our calculator, we have to make sure we close our parentheses if we're using the graphing one. Yep, that's the same thing we got in the first place. It's just where I got it from, where we get it from. Okay, so I'm going to turn my calculator on here and take the log of 7 divided by the log of 4. When you do that, you want to make sure that you close your parentheses after the 7. And then the second parentheses doesn't absolutely have to be closed. And we get 1.404 to 3 decimal places. Your book is going to ask you for it to 3 decimal places. Change of base. Everybody remember that? All right, then you don't have to write a lot down this next one because that's our change of base theorem. Question? Oh, good. All right, change of base says that if we have a log base a of x, we can take the log base something of x divided by the log base same thing of a. And the two log buttons that we have are log base 10, our common log, and, and natural log, log base e. So those are on the calculator. So when we want to find the log base a of x, we simply divide the log of x, or the natural log of x, over the log of a, or the natural log of a, but we don't switch them. Okay? All right, next slide. So how are we going to find the log base 6 of 9? Let's pick on Caleb. How are we going to do it? Good. Okay, somebody with a calculator handy, what do we get? 1.226. Now let's see if that's reasonable. 6 to something a little bit more than 1 is going to get us 9. That makes sense, right? Because 6 squared would be 36. That's too big. Okay? So, Levi, what are we going to do to find the log base 2 of 14? Good. And someone with a calculator, what do we get for that? Here's 0, I'm sorry. 7. Thank you. Does that make sense? 2 to something a little bit more than 3 is 14. 2 cubed is 8, right? 2 to the 4th would be 16. So it needs to be closer to 4 than 3. Okay? All right, what about this one? How are we going to divide it? What do you think, Andrew? Good. Or 0.25, right? Okay. And what do we get? Seven, 8, 9? 7, 9, 2, thank you. Okay, does that make sense? That it would be a negative. Let's think about that. If we had 1/4 to a negative power, that's going to bring that up, right? And make it 4 to the 1.8-ish, right? And 4 squared would get us 16, so that's a reasonable answer. Okay, feeling good about these? All right, next one. All right, now back to no calculator. Okay, when we say no calculator, that just means that these are numbers that aren't going to be 1.786, right? They're going to be numbers that we can recognize, use, and so forth. They'll be rational numbers. They'll either be integers, positive or negative integers, or fractions that we can work with. Okay, so log base 4 of 64 is going to be what? 3. Why? Perfect. Okay, 4 cubed is 64. 4 times 4 is 16, times 4 is 64. Log base 2 of the cube root of 32. What power is the cube root? 1/3. So we have the log base 2 of 32 to the 1/3 power. Okay? Because cube root's 1/3, square root is 1/2, fourth root is 1/4, fifth root is 1/5, right? When you get to the fourth root, it makes sense, but the cube root should really be the third root and the half root if we really wanted to make it easy on you, okay? So how are we going to solve something like that or evaluate it? What if we let this be equal to x? How would we write that as an exponential expression or an exponential function? Perfect. Okay. And remember from 2 days ago, if we can get our bases the same, then we can get our powers, the exponents the same. So 32 is 2 to the 5th. So we have 2 to the x and 2 to the 5th to the 1/3 power. And you told me a little bit ago that when you have a power to a power, you multiply. So this is 2 to the x equals 2 to the 5/3. So what's x? Okay. All right, so next one. Log base 3 of 1 over 81. -4. Why? Because 3 to some power is 1 over 3 to the 4th, right? And so it has to be -4. Questions on this slide? In order to make our, we had it down here in the denominator, right? So if 3 is to the x as 1 over 81, we want to make that into a 3, a power of 3, and 81 is the same thing as 3 times 3 times 3 times 3. So let's give it, take it out of the bottom and make it a negative power so they're level. And so it would be 3 to the x equals 3 to the -4 when we bring it out of the denominator. So x has to be -4. So far, so good? Okay. All right. Properties of logs. Give me a moment to write these down. I forgot about yesterday. Sorry. So we have a product property, we have a quotient property, and we have a power property. It helps to remember that relationship between logarithms and exponents. When we multiply like bases, what do we do to the powers? Two to the 5th times 2 to the 3rd is 2 to the 8th. What did you do? Added the powers, right? So if we're multiplying, we make them into 2 separate logs being added. Separate them out. That's called expanding. And it doesn't matter if you're using the log base A or the natural log or the log base 10, our common log. When we're dividing, What do? Subtract. So we can separate these, expand them into two logs with a minus sign in between. And a power to a power, we said earlier, we multiply, right? So we can bring that power out in front and multiply it by the answer, the log, which is the answer to the exponent. Okay, so how would we condense 3 times the natural log of the quantity x minus 5 plus the natural log of x? I want to make it so tight that we only have one natural log when it's all said and done. So suggestions? What do you think, Jax? What is this 3 going to do? Before it said if we have a power out here, it can go to the front, right? So if it's in the front, it can go up there. So it's in the front, so it's going to go up here, right? Okay, so this guy's moving up here. We'll have the natural log of x minus 5 cubed. Let's do this in 2 steps. Okay. And Caitlin, what are we going to do with these two? Multiply. So we want to make it one natural log. And it's okay if you put the x in the back, but most of the time we would likely put x in front. Right? Erase and retry. Okay. And we're done. Good question. So this is as far as we can go with this one because we don't have an e anywhere and so forth, right? So the natural log of x and x plus 5, there's nothing more we can do. If we get to a point where we have it condensed and we can evaluate some of it, then we would evaluate it. Or if we get to the point where we have expanded it or are trying to expand it so that we can simplify, that's great too. We can remember our properties from before. Okay? There will be a chunk on your assignment that you'll be asked to do that. All right, next one. 1/2 times the quantity log base 2 of x minus log base 2 of the quantity x plus 4. So let's handle that power real quick, right? This guy's going to go out, right? Or we can multiply it through, right? Everybody okay with multiplying it through? Let's distribute. Okay. So we have a couple of logs there, and we've got that 1/2 to deal with. Shall we bring the 1/2 up now? Log base 2 of x to the 1/2 minus the log base 2 of x plus 4 to the 1/2. Now how do we make it just one log? Division. Log base 2 of x to the 1/2 over log base 2, or not log base 2, just plain old x plus 4 to the 1/2. And if you want to call them square roots instead, you can. And we're done. Take them in steps. Do one thing at a time. Use one of the properties at a time. Questions on this slide? Excuse me. Here's your assignment.